1. At 12 midnight, while the temperature inside a house is 23 degrees Celsius and the outside temperature is negative 7 degrees Celsius, its furnace breaks down. 2 hours later, the temperature inside the house has fallen to 10 degrees Celsius. Assume that the outside temperature remains at negative 7 degrees Celsius. The Newton laws of cooling states that the rate which the temperature T changes in the cooling body is proportional to the difference between the temperature to the surrounding medium. Let's look at the solution. According to the Newton's law of cooling, we have a formula of dt over dt. Capital T stands for temperature and small t stands for time, whereas we have K, which stands for constant, and in bracket T minus Ts. Ts stands for the temperature of surrounding. Since the temperature of surrounding is given where it is negative 7, we can substitute negative 7 into the formula. Now we have the differential equation.
Here, I would like to explain question 1b. First of all, we need to apply Newton's law of cooling to this problem. Let me see step by step. First thing, we must write d of t with respect to time, that is equivalent to k, and then we have temperature minus the surrounding temperature, which is equivalent to negative 7 degrees Celsius. Here we will get change in temperature with respect to time, which is equivalent to k bracket t plus 7. After that, we must make some arrangement for this one. So here we will do separation of variable by combining t with dt. So here we will get dt over t plus 7 equals to negative k dt. And then in this differential equation, we need to integrate both sides. By applying integration both sides, that becomes this one integral of dt over t plus 7 is equivalent to ln t plus 7, and then integral of negative k dt will become negative kt plus c. After that, we need to transfer ln to the other side. So here we will get a equation which is t bracket of small t is equivalent to negative 7 plus c exponential raised to negative kt. Okay, as the next step, we must find out some unknown variable by using the equation that we find out just now, which is t bracket of small t equals to negative 7 plus c exponential raised to negative kt. Here, from the question, we already get to know that is when the time is equal to 0, the temperature was 23 degrees Celsius. So here, we must substitute the value of temperature 23 degrees Celsius and then time as 0 in the equation. So, after we substitute, we will get c equals to 30. So here we already find out the unknown variables
3:14 am.
c is equals to 30. So, as the next step, we must substitute the value of c into the equation. So here we will get t bracket of small t is equivalent to negative 7 plus 30 exponential raised to negative kt. Step, we must find out the value of k. From the question, we already know when the time was 120 minutes, the temperature was 10 degrees Celsius. So, we must substitute the value of t as 120 and the temperature as 10 degrees Celsius in the equation that we find out just now, which is t bracket of small t equals to negative 7 plus 30 exponential raised to negative kt. After the substitution, we will get 10 equals to negative 7 plus 30 exponential negative k bracket of 120. So after that, we will get 17 over 30 is equivalent to 30 exponential negative k bracket 120 over 30. So here we will get ln 17 over 30 is equivalent to ln exponential negative k bracket of 120. So after do some transformation, we will get k is equivalent to 4.73322 times 10 power of negative 3. So here we already find out the value of k. After that, we again need to substitute the value of k into the equation. So after the substitution of the value of k, we will get the equation which is t bracket of small t is equivalent to negative 7 plus 30 exponential raised to negative 0.0047332 t as the final answer. So we have it already done for this question.
Question. Determine at what time when the temperature inside the house reach 5 degrees Celsius. After a few hours, what's time when the temperature inside the house drop to 5 degrees Celsius? By using the formula Tt equal to negative 7 plus 30 exponent to the power of negative kt, so we will apply our given condition at T is equal to 5 degrees Celsius. So we substitute this one to at T equal to 5. Then 5 equal to negative 7 plus 30 exponent to the power of negative 0.004733 T. Now we will continue to find the value of T. So we will apply ln to the both sides of the equation. So ln 2 over 5 is equal to ln e exponent to the power of negative 0.004733. So how we get 2 over 5? Because we just simplify it to the lowest term. So ln 2 over 5 equal to ln e to the power of negative 0.0047333 t. So the value it will become ln 2 over 5 equal to negative 0.0047333 t. Okay, then ln 2 over 5 is equal to negative 0.9163 equal to negative 0.0047333 t. Now we can find the value of t. So t is equal to 193.6 minutes, or we change to the hour, it will be equal to 3.23 hours. The time when the temperature inside the house at reach 5 degrees Celsius is.
Next, we move to question number 2. The question is, a large tank contains 20,000 liters of pure water. Brine containing 5 kg of salt per liter is pumped into the tank at a rate of 20 liters per minute, and the well-mixed solution is pumped out at the same rate. Find the amount AT of salt in kilogram in the tank at time t. So, as we can see here, this is how the questions look. We can see here at the top, 5 kg of salt per liter is pumped into the tank. After well mixed, it's pumped out of the tank, as you can see at the bottom. Both of these situations is pumped at the same rate, which is 20 liters per minute. So, from this question, we have got the amount of fluid in the tank, which is 20,000 liter. Next, rate of pumping in, which is 20 liter per minute. The initial amount of salt, which is 5 kg per liter. So we can label as 80, which is 80 is amount of salt in the tank at time t. We also can label R as rate of pump. Next, the question asks us to find the AT. So, to find AT, we can use the dA per dt. The dA per dt, well, that's going to remember notationally on the left that says the change in the amount of salt with respect to time. Intuitively, how would you get the change at the amount of salt with respect to time? Well, I guess intuitively it would be the rate in of the salt minus rate out of the salt. Next, we calculate the R in, which is rate in, minus R out to get the dA per dt. To find R in, we calculate as 5 kg per liter times with the rate, which is 20 liter per minute. To find the R out, we calculate as 80 per 20,000 liter times with 20 liters per minute. And then we just calculate using the equation, which is R in minus R out. Then we will get the dA per dt is equal to 100 minus 80 per 1000.
So the standard form is dA over dt plus A over 1000 equal to 100. The linear differential equation is dA over dt plus 1 over 1000 times A equal to 100. Next, we identify P of t from linear differential equation and find the integrating factor, which is V of t. The formula for integrating factor is V of t equal to exponential of the integrate of P of t with respect to t, which is exponential of the integrate of 1 over 1000 with respect to t, and we will get exponential of 1 over 1000 t. Then, we multiply the linear differential equation by V of t, then we will get exponential of 1 over 1000 t times dy over dt plus 1 over 1000 times exponential of 1 over 1000 t times y equal to exponential of 1 over 1000 t. Next, we differentiate the product of V of t and y, which is differentiate exponential of 1 over 1000 t times a, and we will get exponential of 1 over 1000 t times 100. After that, we integrate both sides of equation, and we will get a times exponential of 1 over 1000 t equal to 100,000 times exponential of 1 over 1000 t plus c. Then we divide exponential of 1 over 1000 t both sides, and we will get a equal to 100,000 plus c exponential of negative 1 over 1000 t. The last step is we apply the initial condition, which is a of 0 equal to 0. Then we will get c equal to negative 100,000. So the amount of salt in kilograms in the tank at time t is a of t equal to 100,000 minus 100,000 times exponential of negative 1 over 1000 t kilograms.